So still under the 2023 examination question. This is question number 3A. So we are asked to find the derivative dy dx given that x cubed over x plus y is equal to 2 for the first question, and then this and this for the second and third question. So let's begin with the first one. So we have um, x cubed over x plus y equal to 2. We are asked to find dy dx. But first, let's express this in terms of y. Let's express it in terms of y because it is very easy for us to express it in terms of y. So first of all, from here we have x to the third power equal to 2 into x plus y. Then the next thing there we have is x cubed over 2 is equal to x plus y. So send x over to this side. We have x cubed over 2 minus x equal to y. So which implies that y is equal to x cubed over 2 minus x. Then we can now go ahead and differentiate y now with respect to x. So let's differentiate y with respect to x. We have dy dx is equal to, because 2 is a constant, it does not affect the numerator. So what we have, differentiate x cubed, you have 3x squared. So we have 3x squared here divided by 2. Then if you differentiate x, you have 1 minus 1. So that is the answer to I. So let's move on to II. Let's move on to II. So I'm still going to be cleaning this part so that this part remains. I'll clean this part. II. II there says y is equal to sine 3x over x plus 1. That's what we have. So the II there says y is equal to sine 3x over x plus 1. So we have to find dy dx. But since we have a rational function, so we need to apply the quotient rule. And remember the quotient rule. The quotient rule says v du dx minus u dv dx over v squared. And what is our u and what is our v? The top is our u and the denominator is our v. So let's quickly apply the quotient rule. So we have dy dx to be equal to, the quotient rule there says v, and our v is the denominator, which is x plus 1. So we have x plus 1 times du dx, which is the derivative of the top. And of course, if you differentiate sine x, what are we going to have? First of all, differentiate 3x, you have 3, and then differentiate sine, you have cos. So we have 3 cos 3x. Then the next one there we have is minus u. Our u is sine 3x, sine 3x into, you differentiate v with respect to x. So if you differentiate x plus 1, you have 1. But if you differentiate x, you have 1. And if you differentiate 1, you have 0 over v squared. And v is x plus 1 squared. X plus 1 squared. So the y dx have to be equal to, we can decide to multiply this out, or we can decide to leave it in this form, or we can still decide to multiply out. So which way are we going to do? Okay, let's write it in this form. 3, we are going to have 3 into x plus 1 cos 3x minus sine 3x over x plus 1. And that is the answer to that given problem. So let's move on to I. Because of no space here, I'm still going to be wiping this. So I there says y is equal to exponential 2x ln 5x, and we are to find dy dx. But because this is a function of x and this is another function of x, so we have to apply the product rule. And the product rule there says u dv dx plus v du dx. And this is our u and this is our v. So let's apply the product rule here. So we have dy dx to be equal to, the rule there says u and our u is exponential 2x. So we have exponential 2x times dv dx. This is our v, ln 5x. So dv dx simply means differentiate v. So how can we differentiate ln 5x? First of all, look at how to differentiate ln or log function. You first of all differentiate what you have here, 5x. If you differentiate 5x, you have 5. Then you rewrite the whole function attached to the ln. So what we have there is, first of all, write the 5, then you divide it by the function itself, 5x. Please, let's observe this again, how to differentiate it. First of all, you differentiate what you have attached to the name. 5x, you differentiate 5x, you have 5, and you divide it by that thing you have, which is 5x. Then the next one there is plus v. Our v is ln 5x, ln 5x times du dx simply means differentiate u. And how can we differentiate an exponential function? To differentiate an exponential function, first of all, differentiate the power. If you differentiate the power, you have 2. So you write down the 2 and then you multiply it by the entire function, exponential 5x. So that is what we have. So dy dx must be equal to 5. We cancel 5. So we have 1 over x. So we have 1 over x exponential 2x plus 2 can come over to this side. 2 exponential 2x ln 5x. Okay, this is 2x, not 5x. 2x. Remember, 2x. You differentiate the top, you have 2, and you multiply it by the entire function you differentiated, which is exponential 2x. So that is the answer to that given question. Question number 3b. The question there says, if y is equal to x over x over exponential x, show that the square y over the x square, which is the second derivative of y with respect to x, plus dy dx, which is the first derivative, is equal to minus exponential minus x. So we have to show that these two, the sum of these two, is equal to this. So let's start. We have y to be equal to x over exponential x. So to start the differentiation, now I would like us to express this. This is a rational function. Now we have to use quotient rule, because quotient rule seems so difficult, or it's not difficult, but it seems like it is difficult. So let's express this in terms of product rule. So we are going to have x exponential x to the power of what? Minus 1. That is what we have, because 1 over exponential x is the same thing as exponential x to the power of minus 1. And this is going to give us x exponential. Remember from the law of indices, you can use x to multiply minus 1. So x times minus 1 will give us minus x. So we have that y is equal to x exponential minus x. So we can now differentiate this using our product rule. So let's start. Y is equal to x is equal to x exponential minus x. This is our u and this is our v, and the product rule says u dv dx plus v du dx. So let's start. Y, which implies that dy dx must be equal to u, we have x, times dv dx. Dv dx simply means differentiate exponential minus x. And how can you differentiate an exponential function? First of all, differentiate the power here. You have minus 1, so you bring down the minus 1 and then rewrite the whole function exponential minus x plus next one there is v. Our v is exponential minus x times du dx. U is x, so if you differentiate it, you have 1. So dy dx will be equal to minus 1 times x will give us minus x exponential minus x plus exponential minus x. So that is what we have. So we have find dy dx. So the next one we need to find is the square y over the x square. The square y over the x square simply means we differentiate dy dx in this form. Differentiate with respect to x of dy dx. So multiply this out. You have the square y over the x square. So what we want to do is to redifferentiate dy dx and then obtain the square y over the x square. So how can we differentiate that? Because because these two are multiplying, we still need to use product rule and then just differentiate this one. So the square y over the x square simply means differentiate this very guy again. So we have minus here. Now to differentiate it, this becomes our u, this becomes our v. So the product rule there says u, which is x, plus times dv dx, which is x. Dv dx simply means differentiate exponential minus x, and to differentiate that, the same thing here. We have minus 1, differentiate the power, you have minus 1, then you rewrite the entire function exponential minus x. The next one there is plus v. Our v now is exponential minus x times du dx. Du dx simply means differentiate u, and our u is 1, x. So if you differentiate x, you obtain 1. This is what we have. Then plus differentiate this guy. Remember, to differentiate this, you differentiate the power. You have minus 1, and then write the function again, exponential minus x. So let's evaluate and see what we have. Minus times minus will give us plus. So we have x exponential minus x. That is what we have there. Then minus times plus will give us minus exponential minus x. Then plus minus times this will give us minus, becomes minus exponential minus x. So that is what we have. But the question this didn't ask us to only find this. We should find this and then add it up with this, the square y over the x square plus the y dx from the question. So let's add these two. So what we have is, I'm going to add that up over to this side. So we have the square y over the x square plus the y dx, and this is equal to the square y over the x square gives us this. So we have x exponential minus x, then the next one is minus exponential minus x, minus exponential minus x. We can still add these two up to obtain 2 minus 2 exponential minus x, but we can still leave it this way, sha. Then the next one there we have is minus x. For the y dx, we have minus x exponential minus x. Then the next one we have is plus exponential minus x. So let's cancel out this, we cancel this, and this, we cancel this. So therefore, the square y over the x square plus the y dx is equal to minus exponential minus x, which is what they asked us to prove. So we have just proved that. So that is the answer to that given question. So I'm going to see you on question number 4, 5, 6, and 7 from the next video. So if you are new to the channel, do well to subscribe so that and click the notification button so that you'll be notified whenever I upload a new content.